All right, welcome back. Welcome back. Yes, we're gonna take a look at the chain rule. I like to do the chain rule as f prime of g of x, g prime of x is the derivative of um, the derivative of f of g of x. That's my preferred notation there. Okay, we're gonna do it in terms of y and u. This one we're gonna let u be the g of x. So u here is the x plus 3. And if you notice, if I let u be x plus 3, see how y is negative 5 over u cubed? So that's kind of like g of x and f of x, right? G of x is the u, f of x is the y. And let me rewrite that y as negative 5 u to the negative 3. So when we take this derivative, negative 5 u to the negative 3, what we're going to do is we're going to take the derivative f prime g of x. Let me underline it right there. So that'd be negative 5 stays there. I got negative 3, then it's u, then it's to the negative 4. So there's my 15u to the negative 4. But then I got to take g prime of x. And that's the derivative of the u right there. So derivative of x is just 1 plus 0. And then don't forget, you do have to replace the u. So that's 15u to the negative 4 times 1. Replace the u. And then write it without a negative exponent. So we got 15 over x plus 3 to the 4th. All right, this one we've got, here's our y equals, let's see, I'm going to let my u be, oops, let me erase that. I'm going to let that u be the inside again. So u is 1/6 x to the negative 1 minus a 1/6x. Okay, so if the u is the inside, y would be the u all to the 6th power, right? And so when we take the derivative would be 6u to the 5th, right? And this is my u to the 5th. Remember, I got to replace that. And then I got to take the derivative of u, right? In other words, that right there is the f prime g of x. Now I got to take g prime of x. So I got to take the derivative of this right there. Derivative of u. So the 1/6 stays there, and I go negative 1 x to the negative 2 minus 1/6 times derivative of x is 1, right? And then make sure you replace u with what it is. So let's put it in. 6 6x to the negative 1 minus 1/6x. All right. So let's clean this up. And I got negative 1/6, and then the x is squared down there, and then minus 1/6. Now notice that is to the 5th power, right? I have that u to the 5th power. So I'm going to take this 6. I can't take it through to that 5th power because I would have to expand the 5th power. I don't want to do that. So let me take it over here to this one, though. I can distribute it right there. So this one stays here. And then that would be negative 6 over 6x squared. That's negative 1 over x squared. And 6 times negative 1/6 is just a minus 1. And there's your y prime, or if you want to call it dy dx, same thing. Okay. All right, here I'm going to let my u be that cotangent. So if u is the cotangent, then y would be the cosecant of u. Okay. And so then we're just taking the derivative there. So let's go ahead and take the derivative. So y prime would be the derivative of the cosecant is negative cosecant cotangent. So negative cosecant u cotangent u. Okay, that's my u. Remember, I'm going to replace that. So there's the derivative of f prime of g of x. Now I've got to take the derivative of the u, right? So I've got to take the derivative of g prime, if you will. So derivative of the cotangent, negative cosecant squared. So derivative of cotangent, negative cosecant squared. This is theta. All right, let's replace the u's with what it actually is. And then we got, notice I got a negative times a negative. So, and this is dy d theta, by the way, not dy dx. That should be a dy d theta. Negative times a negative is a positive. And there's nothing we can do after that. We're just done right there. Let's go to this next one. I'm going to let u be that 9x minus 7. And so y would be u to the 4th. And then we go ahead and let's go ahead and take that derivative. So dy dx would be 4, again, u to the 3rd. And now we got to take the derivative of u. So we got to take the derivative of 9x minus 7, which is just 9. And let's go ahead and replace the u. So u is 9x minus 7, the 3rd is 9. So 9 times 4, we got 36, 9x minus 7 to the 3rd. And there's our dy dx on that one. Let's go ahead and let our u be that radicand there. So our u is that 3x squared minus 4x plus 6, which means the y would have to be u to the 1/2, or the square root of u. And now let's go ahead and take the derivative. So dy dx would be 1/2 u to the 1/2 minus 1, so negative 1/2. And I'm going to put the u in. And now, don't forget, I still got to take the derivative of u, right? Chain rule. This is the chain rule part. I'm taking the derivative of the inside. So 6x minus 4. So I got 1/2 of 6x minus 4. And then I've got this 3x squared minus 4x plus 6, all to the negative 1/2. Well, if I take the half through, I got 3x minus 2, and this is all to the negative square root, so let me just take that down. And there's my dy dx. 3x minus 2 over the square root of 3x squared minus 4x plus 6. So if you look at this, you're like, hey, what's my u going to be? Hopefully you see that it's the sine. Use the sine of x, so that means y would have to be u to the 5th, right? Because it's the sine of x to the 5th power. So when we take dy dx, it's 5u to the 4th, 5u to the 4th. And remember, our u is the sine of x. And that's the derivative of that sine. It's the derivative of u, right? Derivative of the sine is cosine. So this just ends up being 5 cosine x sine of x to the 4th. Let's do that next one. Let's let u be the inside again, so that u would be x to the 7th minus 5 x to the 4th. So y would be all of that, the 6th root of that. In other words, u to the 1/6 is the same thing, right? I want to be able to use the power rule here. So when I take the derivative dy dx, I'd have 1/6 u to the 1/6 minus 1. Well, that would be negative 5/6. And I'm going to go ahead and put my u in. And then the derivative of u, well, that'd be 7x to the 6th minus 20x to the 3rd. And so dy dx ends up being 7x to the 6th minus 20x to the 3rd over 6 times that x to the 7th minus 5x to the 4th all to the 5/6. All right, hopefully when you take a look at this, you see a product rule. Let me rewrite it this way. I have x, and I have this 4 plus x squared to the 1/2. Now the x is fine, but the 4 plus x squared to the 1/2, I'm going to have to do chain rule on that, right? And by the way, this is like my f, this is like my g. So when I take this derivative, I'm taking the derivative of the first times the second one, so the second one stays the same, plus the first. Now I'm taking the derivative of the second one, so this one right here. I'm taking that derivative. And I'm just going to do it all at once. I think you've seen a few of these chain rules, so I'm going to go, it's 1/2, the quote u to the 1/2 minus 1, which is negative 1/2, times the derivative of the inside, which is 0 plus 2x. And I just took that derivative, right? If you want to go out to the side and let u be 4 plus x squared, and y be u to the 1/2, and do it that way, you can do it that way, right? But I'm just going to run it right now. But go ahead and practice that if you need to. So we got square root of 4 plus x squared plus, I got x times 2x all over 2. These 2's cancel. So x times x, I got x squared there. Over square root of 4 plus x squared, right? And then I would just go ahead and get a common denominator here. So this is over 1. Let's go ahead and give it a square root of 4 plus x squared, square root of 4 plus x squared. So then I got y prime equals square root of 4 plus x squared times square root of 4 plus x squared undoes the radical. So y prime equals 2x squared plus 4 over square root of 4 plus x squared. I guess you could take a 2 out if you wanted to as well in factored form with the numerator, but that'll suffice, either one of those. Totally fine. Here you've got a quotient rule now, this next one. So the top is f, the bottom is g, and so you've got the quotient rule involved here with your chain rule, right? So let's go through the quotient rule. So I got this derivative would be derivative of the top. So here's the derivative of the top. Now it's to the 3rd, but don't forget I got to take the derivative of 6x, which is 6. There's the derivative of the top. Times the bottom. So this bottom just stays the same. Times the bottom. Minus the top. And now the derivative of the bottom. Again, chain rule. 5, 2x plus 1. Now it's got to be the 4th, and the derivative of 2x, which is just 2. All over bottom squared. And now we just got to clean this up. So I got 24. And that's 2x plus 1 to the 10th. I'm going to go ahead and looks like I can take out a 2 and 3 of these 6x plus 1s and 4 of these 2x plus 1s to the 4th. And I would be left with, let's see, I'd be left with a 12. I'd be left with one more of these 2x plus 1s from that one, minus I'd have a 5, and I'd have one of these 6x plus 1s left. And I notice I'm like, okay, I got 4 of these 2x plus 1s on the top, 10 of these on the bottom. So I'm left with 6 of those left on the bottom, right? And then I would go ahead and do this too as well, combine those. So let's see what we got. Y prime 2, 6x plus 1 to the third. And I've got 24x plus 12 minus 30x minus 5. This is all over 2x plus 1 to the sixth. Let's see, 24x minus 30x, I got a negative 6x. 12 minus 5, I got a 7. You know, I'd probably take a negative out of that, put it out front. So I had negative 2. And that'd change that to a positive 6x minus 7. It's just kind of a preference thing. I'd call it good right there. All right, so this one, if you've imagined the inside of this, that quotient, t squared over t cubed plus 2, that's like your u. So this is like u squared, right? So when I take this derivative, I'm going to have the 2 in front, and here's my u. And now it's to a first power, right? So I don't need to put a 1 up there. But I got to take the derivative of that inside, which means I got to use the quotient rule now. So I have all that here. Let me erase this. I have a little room here. Now I got to do the quotient rule, which is derivative of the top times the bottom minus the top, derivative of the bottom, all over bottom squared, right? So then it's just a matter of cleaning this thing up. So I got 2t squared over t cubed plus 2 times two t to the fourth minus 3t to the fourth. I got a negative t to the fourth, so I got 4t minus the 1t to the fourth. This is all over. I have t cubed plus 2 times t cubed plus 2 squared. So I have 3 of these t cubed plus 2's. And I'd probably just take a t out of each of those. And then multiply by the 2t cubed. 2t squared. Oh my gosh, I'm sorry. That's a squared right there. I'm sorry, you guys. Squared, squared, squared. Shoot me, sorry about that. So now it's a cube, 2t cubed. And there's your derivative. Sometimes you have to use the chain rule more than just one time. Like in this case, you know, like your h of x, I'll call that the innermost, would be the 9 theta. Your g of x would be the cosine of that. Cosine of the h of x, right? And finally, the f of x is the sine of that g of x. All right. So when you're taking the derivative, let's just go ahead and take it. you say, all right, the derivative of the sine is the cosine. So I have the cosine of that stuff. Now I'm taking the derivative of the cosine. So I'm taking the derivative of the cosine. The derivative of the cosine is negative sine. And then I got to take the derivative of the 9 theta, which is just a 9. Right? So this f prime of theta just ends up being, let's take that negative 9 out front. Negative 9 out front, I have the cosine of the cosine of 9 theta times just the sine of 9 theta. And that's our derivative. Okay, so you had, in this case, it was set up, let me give it to function notation, is f prime g of h of x, g prime h of x, and then h prime of x. Right? This was the h prime, this was the g prime, and this is the f prime right there. Right? So repeated chain rule, if you will, or using the chain rule more than once. Let's keep going here. So here we got the cosine. We're going to take the derivative of the cosine, which is negative sine of this stuff. Now we take the derivative of that, which is 3/4. That, 3/4 minus 1, negative 1/4. Now we got to take the derivative of 4x plus 7, which is good. And now notice I got, let's see, I got 3/4 times 4, I got 12/4, so I got 3. So I got, and then I got the negative in front. I got negative 3 sine of that 4x plus 7 to the 3/4, and then this 4x plus 7 to the 1/4 is down there at the bottom as a positive 1/4. And there's our dy dx. And by the way, you can't, it's not like you can use this rule, right? Don't try to do that because you got the sine of that 4x plus 7 to the 3/4, right? A sine is being run on that. So you can't do that. You can, in other words, you can't simplify that 4x plus 7 any further. All right, let's keep going here. Y is 2 cotangent squared. So y prime would be 2 stays there. And then this is power rule. So I'm going to take cotangent squared. So 2 goes in front. Now it's the cotangent of that. And then I'm taking the derivative of the cotangent. Well, derivative of the cotangent is negative cosecant squared of that. And then I'm taking the derivative of pi x plus 2, which is just pi. Okay, and it looks like I got 2 times negative 1 times 4 out front. So I got negative 4 pi out front. And then I got this cotangent pi x plus 2. And then I got cosecant squared of that pi x plus 2. And that would be my derivative there. And, you know, if you're thinking about like sines and cosines, you know, cotangent's cosine over sine, cosecant's 1 over sine squared. So it's not like anything like really cleans up here, right? Even if you were to convert it. All right, let's do it with the e. If you remember, anytime we have a to the x, the derivative is ln a times a to the x. Well, in this case, we have the chain rule. So when we take this derivative, we still have ln e, we still have this e to the negative x squared, but we got to run the chain rule. The derivative of negative x squared, negative 2x. And we know the natural log of e is just 1, so this just ends up being negative 2x over e to the x squared. And that's our derivative. Let's do another one, a little bit different on this one. You've got the power rule first. So 6, that stuff now to the 5th. Now we're taking the derivative of e to the sine of x over 2. So we got ln of e to the sine x over 2. And then we got to take the derivative of the sine x over 2, which is cosine x over 2. And then we got to take the derivative of 1/2 x, or x over 2. We got to take the derivative of 1/2 x, which is just 1/2. Right? I'm taking the derivative of that inside as well. Well, 6 times 1/2 is 3. Right? I multiplied 6 1/2 times 1/2 there. And then I'm going to go ahead and put my cosine of x over 2 next. I know the natural log of e is just the ln of e, right? So I got e, and let's see, what else am I missing? E to the sine of x over 2, but I don't have just 5 of these now, I have 6 of these now. And that would be our derivative. Or if you want, you could even take that. Remember the rule a to the m to the n is a to the m times n. I could take that 6 in, right? So that's a power of a power. If you wanted to put it, this is the same thing. That's the same thing. All right, we got one more here. Let's go ahead and take this dy d theta. So we would have the derivative sine is the cosine of that stuff. And then now I got to take the derivative of the inside. Well, I'm going to have to do the quotient rule, right? So derivative of the top is 1 times the bottom, square root of theta minus 4, minus the top, derivative of the bottom. Now the bottom is theta minus 4 to the 1/2, so that's 1/2 theta minus 4. Now it's to a negative 1/2, and then the derivative of theta minus 4 is just the 1. Don't forget chain rule on that. All over square root, all over the bottom squared. And so now we just got to clean this up. And then this is all over theta minus square root of theta minus 4 squared, so that'll just undo the radical. And right now this is over 1. I got to get a common denominator there. So I'm going to go ahead and multiply by 2 square root of theta minus 4, 2 square root of theta minus 4 to get that to be a common denominator. And so I have 2 times, now square root of theta minus 4 times square root of theta minus 4 will undo the radical. These are all over that common denominator. And then this is all over theta minus 4, right? And of course, when you're going 1/2 divided by 1/3, right, I'm going to multiply by the reciprocal, right? So that's what I'm going to do here. So this is, right now, this is theta minus 4 all over 1. So I'm going to go ahead and multiply by 1 over theta minus 4 to get rid of that. And I'm going to distribute that. So I have 2 theta minus 8 minus theta. This is all over 2 square root of theta minus 4 times theta minus 4. So we have 2 theta minus theta is a theta minus 8. And then I have a 2, and then theta minus 4 to the 1/2 times theta minus 4 to the 1. You know, a to the m, a to the n, a to the m plus n, right? So 1 plus 1/2, 3/2. Call it good right there. Appreciate you watching. I hope that helps get you started. See you next time.